So good afternoon, everyone. Since I'm not very in Japanese, I'm going to explain everything in English in this session. So before going to the artificial neural network, so I have named this session as thinking machine because we are going to learn something about how to implement thinking ability into the computer. So before that, I'll just introduce about myself. I'm Sameera, and former coming to Japan, former I was a assistant lecturer in the statistics and computer department in University of Perceptron, Sri Lanka. So I graduated there as a PhD computer science specialist. So I worked something like 2 years in the University of Perceptron. So that is about my education or qualifications. And then after that, what type of experience that I have in the artificial intelligence (AI) is that I had a course theory work called 401 in my 4th year. So there I have learned about the artificial intelligence and this topic neural network, some algorithms. So after learning that 4th year, that course material, after taking the course, I have done my research, 4th year research, AI-based research. In that AI-based research, what I have done was predicting stock market price, Sri Lankan stock market price. So predicting that stock market price, so I will explain about my research also at the end of this session when we are discussing about some examples. So that research took about 1 year to get to the final result. It was like 45% successful, not that much successful, but I have some experience in the AI neural network field. So from here on, we each page is speed. How I'm speaking is okay.
Okay. AI やってたよって
Right, so these are the things that we are going to discuss under this section. First of all, introduction and a bit of a history of the neural network. And from there onward, background about this session, what we are going to learn from here onward. Then we are going to learn about how our human brain, because these neural networks are inspired. The neural networks, these concepts came from the human brain. So because of that, we have to learn a little bit about human brain. Then neuron, we are going to learn something about a neuron, the unit. So neuron, simple neuron, and how this neural network, these neurons are going to work. Then some topics sometimes called threshold and biasness, and what is an activation function. We are going to learn about those things. So all of these things, all of these topics from here up to here is related to a single neuron. And after that, we are going to learn how these things work, how we can apply these things into our real world projects, real world researches. So we are going to learn those things by examples, and we are going to learn about a neural network. So up to now, from here up to here, we discussed only about a single network, only one network, one neuron. After that, how to connect those networks, how to connect those neurons and create a neural network. We are going to discuss about that one, and types of networks. Some things you have to consider under this network parameter when you are creating a project, the things that you have to think under this network parameter, and what is pre and post processing. I'll show. So at the end of this session, I'm going to show you practically how to do a simple project, something like character recognition, simple project. So there I'll explain again about this pre and post processing and training basics, learning processing, learning process, and neural network, how in what type of fields it is used in the current world, and advantages and disadvantages. So these are the topics that we are going to discuss under this session. Right. So first of all, neural networks. So what are the neural networks? So first thing, so up to now we have C, Java, C++, whatever the programming language. So we are going to create our programs using these languages. What we are going to do here is we give set of instructions to the computer. That is what we do using the if conditions, using the while loop, switch cases. We give instructions. so at the end, so when we are doing the program, we have our that means end solution, what we need as the output. We have that one in our mind because we know the solution. We know that means if our problem was in the real world problem, if our problem was I need to get the 4 plus 5 the result. So I know the final result, how to get the result. So what I'm going to do is いいですか？
随時なんか要約とか入れた方がよかったら1ページにそれ入れるし、次の感じがよくやったら
ユニさん大丈夫？本当に？じゃあ説明して聞くだけ
ゆっくりが要約だからね。
Right. So how we use this neural network? So as the background, this is this problem, real world problem, what we need to do. So what we are going to do is something like we take an input from the user, input 1. I'm not going to write the exact code, right? Then we are going to get the input 2, right? So each time every instruction we give. Then I'm going to do result is equal input 1 plus input 2. So this is my code. After that I'm going to display the result. So I know at the end I have to do some kind of an addition to get the final result. So I know everything. So I'm just giving the instructions to the computer. So that is what we are doing in the programming in current work. So the neural network is not something like that. Here we are going to create a structure. We are going to learn about how these structures are created. So consider something like this. This is a neural network. So here we are going to provide set of inputs into this item. All of these things are inputs. We are going to provide inputs, and we do not know the result. I don't know the result. Here I know the result at the end, what I need to do by doing the program. Here I do not know the result. So I'm going to create a neural network and I'm going to provide some set of inputs. After that, this is going to learn by itself what is the result. That is what we are going to. We are not providing the final result. This item is going to learn from the previous experience. So as an example, so at the very beginning, when I'm a child, so my mother showed me this one as a pen. So I grab the shape of this. So I see the pen, saw the pen, and after that I identify the shape of the pen. So then I'm going to learn. So after learning, now when I see this type of an item, I know this is a pen, right? So I am not programmed. I have learned something. So similar thing is done here. So that is what we are going to learn here under this neural. So this is the new paradigm, new method of programming. So they are exceptionally good at performing. So these neural networks are used in pattern recognition example, something like, so when we show a pen to the computer, it is going to identify this is a pen, something like that. So pattern recognition, some other very difficult tasks that we can. So that means if we do not know the solution, consider something like we are going to show this image to the computer. After showing this image to the computer in front of the camera, computer identifies this is A, but I have not programmed to the computer that this is A. I have not given any input to the computer saying that this is A, but the computer identifies this is A by learning itself. So that is where it is using neural network. So we learn about these things step by step. So in different pattern recognition examples and in different other tasks, these neural networks are really important. Then the major feature of the neural network is learn by example. It has the ability to learn by examples as human beings. We are learning by examples. This one is also learning by example.
わかりました。じゃあはい。須藤さんとは分かった？本当？
わかんないです。
分かんないです。 今やってるこのニューラルネットワークっていうのは別に C 言語とか Java とかそういう言語じゃなくて、そのプログラミングいろんな言語で作られるそのプログラミングの技法なんです。で他のプログラミングと違うのは、普通数式とかと一緒に 1+1 は2とか 4+5 は9って結果が分かってて書くんですけど、ニューラルネットワークはそうじゃないんですよ。インプットは決まっているというか、こちらから指定できるんですけれども、自分自身で学習して最適な結果を出すものなので、こういうような数式をやるというよりは、例えばこういうパターンの認識、 A っていう文字を認識するってプログラムで書けないじゃないですか。 A を認識するんだっていうのは書けないので、どこか特徴のようなこういうサンプルを A というのを与えれば、これは A だよって自分自身で学習させて認識させるような技術っていうのを、この後具体的な例を元に説明していってくれると
みんな分かってます。
So that I have added some history, bit of a history about the neural network, because it is not a recent topic in the current future. It has started in 1890 by the person called William James. At this time phase, we did not have anything called neural network. It is just a concept. He has thought about we can apply the thinking ability to the computer, just a concept here. After that, some milestones has been passed. I'm not going to explain everything, but the next most important milestone is this one, the perceptron. This one is equal to neuron that we are going to learn next. Perceptron is the neuron. The perceptron or the neuron is created in this 1958, the major step in the neural network. Then after that, they were doing some researches. So 1969, they have identified some limitations. At the very beginning, they thought that using neural networks, we can do anything. They thought something like that, we can do anything, but that is not the case. In the neural networks, there are some limits. We cannot do anything. So those kind of things were identified in this phase. And after that, the next most important milestone is this one in 1985, which is called back propagation. We are going to learn about this one, just a term here. After that, we are going to learn. So using this back propagation concept, neuron has the ability, after finding this concept, neuron has the ability to learn by itself. So that is about bit of a history. So in the current world, this AI concept is really broad. We are using in different situations. Right. So neural network.
今が歴史で割と機械学習の中で有名な論文たちです。パーセプト論とかバックプロパゲーションとか、そこは参考なので調べておいてくださいというようなものです。ありがとうございます。
So as the background here, artificial neural networks is an information processing paradigm inspired by the biological neural network. So here we are going to create some compute. This is also at the end a computer program which can learn by itself. So this artificial intelligence, so this artificial neural network concept is created by observing human brain, what we have inside our brain, what happens inside our brain. So there is a relationship with the medical field and the IT field here. So in the medical field, they have learned about what happens inside the brain. So that concept is included into this neuron. So here in the brain, so when we consider this is the brain, here we have large number of so-called neurons. These are biological neurons. Similarly, we are going to create another item using the computer program. Here also we have large number of items which are called neurons. These are artificial neurons. These are biological neurons. So here also we have large number of neurons which are connected together. Here also we have large number of neurons which are connected together. So that is we are going. So from this one, we create this one. That is how the neural networks are inspired at the very beginning. So in the artificial neural network is a specific application. So we, as I told you earlier, this can be used for pattern recognition, and again data classification. We'll learn about what is pattern recognition, what is data classification with some examples later. So we are going to use the neural networks, this item, to do these kind of things: pattern recognition, data classification. How these are going to be learned by the examples. So that is about bit of a background here. So next thing, so before we are going to learn about the neurons, we have to learn something about what happens inside our brain. Right here, this is a brain cell, what we call neuron, biological bioneuron, or we call again this one as brain cell. Brain cell. We have a lot of items inside this one. So if I simply draw this biological neuron, it is something like this. Here these things are going to be divided into branches like this. Some set of branches, and here at the middle we have something called nucleus. Then here there is a long axis which is called axon. At the end, these are called synapse. All of it, nucleus, then axon, and synapse. And these items are called dendrites. So how these items are going to work? So in the brain, it is not only one neuron, as I told you. So this one is a single neuron, total one, and there is another, this kind of an item. These two are going to be connected together in this way. So the neuron. So this neuron gets some signal, input signals, and the nucleus is going to do some processing inside. So something like summation, getting the sum of the input signal. So get the summation of the input signal, then it is passed through this axon to the next neuron. This is also similar to this one. And from this synapse, what I call synapse here, this is going to pass the signal to the next neuron's dendrites. So at the end of this neuron, again, this type of an item is here. So these things are going to, the signal is going to pass from this neuron to the next one, and this synapse and the dendrites, these two are not going to be touched. There is a small gap which is called synapsis gap. This synapsis gap. Those two are not touched with each other. There is a small gap. So signal is passing from this neuron to the next one using the synapse and the dendrite. So that is happened from the beginning up to the end. So something like when we touch our hand, there are a set of neurons here. So that those set of neurons will get the input signal that I touched my hand. So those signals will be going from one neuron to the next neuron, that neuron to the next neuron, up to my brain. Then I identifies that I touched my hand. So that is what happens in the neural network inside the human body. So these concepts are going to be implemented inside the neuron, artificial neuron. So human brain, typically neuron collects signals, neurons collect signals, get the signals from the other through the host of fine structure called dendrites. So neuron, dendrites collect the signal from the other neurons. Then the neuron sends out spikes called electric activity. So after that, it is going to sum up the signal, get the summation, and it is going to send the signal to the axis to the next one. So I said over here. So that is what happens inside the human brain. So we are going to apply these concepts to the next level, that means to the artificial neurons. So brain has the parallel processing ability. Parallel processing is there. So when we are creating neural networks, we try to implement that parallel processing ability which is inside the brain. But since the hardware limitation is there, because when we are doing parallel processing, we need a lot of RAM space, lot of processing space. So that is not enough to make the neural network equal to the biological network. So this has high performing power. So something equal to the biological neural network, but it is not totally equal. This is so much powerful. Biological neural network is so much powerful. So inside our brain we have 10 billion, around 10 billion neurons inside our brain. So if we are going to create a neural network, artificial neural network with 10 billion neurons, it is going to have large amount of memory. When it is processing, we need a lot of RAM memory. So that type of processing cannot be done. And the next most important thing is, here when it gets some inputs through the set of dendrites, after that this is going to get the summation, get the sum of all the inputs, and after that it is going to send the signal. When it is sending the signal, if that signal is large enough, so something like here we have a gate. If the signal is large enough, then only it is going to pass the signal to the next one. Something like as an example, so here when we are standing here, we have air around my arm, but I do not feel there is an air around my arm. But when I blow up to my hand, something like this, then I feel, because when I blow up, the air is going to touch with this hand, with the neurons on here on my hand. Then that blowing air power is enough to make some large signal. If the signal is not that much large, so now also I have some air, but I do not feel in my brain that air is there. I need to blow. So when I blow, that blowing air has the power to make large signal, so that that large signal can pass through the gate. If the signal is not large, something like this, these type of signals are not going to be passed. Only if the signal is large, then it is going to pass through the gate. That is again an important concept in neural network. We will see how these things are implemented inside the computer. Actually the thing is, all of these neural networks, all of these neurons are already created using Java, using C#. Then here we are using MATLAB. Everything is created. We just have to use those things. But when we are using, we should have some idea about what happens inside the neural network. Right? So that is about human brain, what happens inside the human brain. Then we are shifting into from the human brain to the neural network. So this is something looks like complex, but it is not that much complex. So right, so this is again, it explains about, it gets the set of signals and passes through the axion to the next one. Only the large signals will be passed. If it is not large enough, it is not going to be passed. The gate is going to stop the signal. Right, so so when we are going to create this artificial neuron, all of these concepts that I discussed now, getting the inputs, get the summation, passing through the network, and if it is large enough, only if it is large enough going through the gate, those things are going to be implemented inside our artificial neuron. So this is the artificial neuron that we are going to discuss. So this is similar to the brain cell, brain biological neuron. Here also we can give set of inputs. All of these things are inputs from the outside or from the next neuron. Here also there is a neuron. That neuron output is going to be input to this one, similar to the human brain. So set of inputs are there. Some processing are going to be done inside this neuron. So this circle is like the nucleus of the neuron. These input lines are like these dendrites of the neuron. Then it is going to pass the signal through the axion. to the next neuron. So these are what we call synapses. Here these synapses are equal to this set of items. So that is how we draw the neuron. So an artificial neuron is a device with many inputs and one output. Always remember, neuron is a device with many inputs and only a single output. We do not have many outputs here, only one output. And neurons connection is here this weight concept is really important. We are providing input, and each and every input we give a weight. For each and every input we give a weight. We will see how to give these weights. For each and every input we give the weights. So this neuron is going to learn by changing these weights. That is the most important concept. So human brain is going to learn by itself by changing something. We do not know actually. Now also we do not know what happens inside the brain. Actually we have some sort of knowledge. Here this artificial neuron is going to learn by changing these weights. We learn how these weights are changed in the next one. Just remember, by the time being, these things will be changed, because input is not going to be changed. It is always input. When we show an image, it is always the image. Only the weights are going to be changed when it is learning. So what happens inside this one will explain. So neuron, this neuron has two modes. First one is training mode. The next one is using mode. Something like, so as I told you at the very beginning, when my mom show him this pen, mom told me this is the pen. So that is my training mode. I was training. But now I am in the using mode. Now I am not going to train. So when I saw this kind of an item, I have trained already. So I know this is a pen now. So same concept. We are going to use set of inputs, large number of inputs, and we are going to provide that set of inputs to the neuron. So it is going to learn at that time. After that, after learning, it is a learned neuron. Now it is okay. We have saved that neuron. So after that we can use. We can show another input. We can give another input, separate input to the neuron. Then it is going to identify what is the output automatically. Something like showing set of pens to the neuron. So it is going to identify this is a pen at the very beginning. And after that, I am going to show another pen. All the pens were red color. So another blue pen was is shown to the neuron. Then it is going to identify this is also a pen, although it is a little bit of different. So using mode is there, training mode is there. We will see how to use a neuron in the using mode and the training mode when we are doing the practical session.
ここまで
So this is
大丈夫ですか？分かってます？
それぞれ一章ずつ説明を言われている。
一応今途中まで人の頭の細胞の話が出てきたと思うんですけれど、このニューラルネットワークっていうのは人の頭の脳の細胞、それをモデルとしてます。で、なのでその1個前の絵が分かりやすいですかね。この一番上のものが人の頭の脳の細胞、10億個の細胞があるものですけれど、それを今度コンピューター上に表現しようと、モデル化しようとしたものがその下のものです。でインプットが複数個あって、でそこに重み付けウェイトがかかって、でそれらをごそごそと計算するっていうのがその真ん中のところで、そこの計算とあとその重みっていうのを自動的にやって最適なものを出しましょうというようなところで、人の頭もそうですけど、ペンを認識するとか、物を認識するっていうのは学習しながら、どんどん賢くなっていって、これはペンだとかこれはペンじゃないとか認識するようになるので、この機械学習もトレーニングモードとユージングモードと使うモードと2種類ありますよというようなところかな。で今人の頭の話をちょっと中心にしながら説明してもらって、で今度はここからより具体的に数式に近いようなところにこれから入っていき